Good afternoon, everyone. Folks, just to give you a recording notice, this lecture is being recorded. You need to contact me if you have any concerns about this. Now, what we are doing now, we started with the probability distributions for continuous random variables. That's what we are doing. So far we have done exponential distribution that we discussed in our last lecture. Now today we are going to start the normal distribution. Normal distribution. Of course, it is for the continuous random variable. It is the most widely used distribution the mean, median, and mode. All these three properties we have already studied are all equal and located at the center of the distribution. So for those of you who are joining us just now, we started with the normal distribution. It is the most widely used distribution. The mean, median, and mode are all equal and located at the center of the distribution. By that I mean to say, now let me draw the curve for the normal distribution. So this is the graph that we are discussing from the start. This is my x-axis and this is my f of x. So the curve of normal distribution is something like this. Okay, basically it is symmetrical. So this point is the mean, the center point here. So by this statement, I mean to say the mean, median, and mode are all equal and located at the center of the distribution. This is your center of the distribution. Now, for example, if I have on axis, let's say I have 36 here, 38, and I have 40 here, 42, 44. So this 40, this value of the 40, I should write it on top. This is basically our mean. This is also equal to our median. This is also equals to our mode, which are equals to 40. So in case of the normal distribution. Now this curve is always symmetrical in normal distribution. And we have studied about these in previous lectures. Now, if you look on this curve, this is kind of the bell basically. Okay, it looks like the bell. So this is why this distribution is also called as the bell-shaped distribution. Now there is another name for this distribution. You will find it in some of the literature. It is called Gaussian distribution. Gaussian. This is S actually. Gaussian distribution. So this is symmetrical. The mean, mode, and the median, they are equal. This is also called bell-shaped distribution or the Gaussian distribution. Folks, I need to go to the next slide, please. Now, how do we denote it? For our random variable x, we denote it as n, and its parameters are mu of x and the sigma of x, standard deviation. This is your mean and this is your standard deviation. This is basically the notation for normal distribution. And these two, the mean and the standard deviations, these are the parameters of normal distribution. By that I mean to say the normal distribution is defined as the mean value and your sigma. Oh, sorry, it's a mean value and your sigma. Let me correct this. Okay, so normal distribution is defined as the mean, which is mu, and your sigma value, which is standard deviation. Now, what is the PDF here? The PDF for normal distribution, as we are talking about the continuous random variable, so it will be a PDF. This is the formula for the PDF. 1 over mu of x square root of 2 pi. This is exp minus 1 over 2 sigma square of x into x minus mu of x whole square. Okay, now this exp is basically the exponential, or you can find these equations in some of the other textbook as 1 over sigma of x square root of 2 pi e power minus x over minus x minus mu of x whole square over 2 sigma square. Now, because this is square here, you can also write it into a third form as this will be 1 over sigma of x into 2 pi exponential power minus 1 by 2 of x minus mu of x over the sigma, and that will be the whole square. Okay, so these are different forms of the equation, but the equation remains the same actually. Now folks, I need to go to the next slide please. Now in terms of the CDF of normal distribution, we have f of x is equals to integral from minus infinity of x 1 over 2 pi square root sigma x and exp of minus 1 over 2 sigma x square times x minus mu of x whole square, and because we are taking the integral, we should have a d of x here. Now in order to solve this, we need to eliminate our integral here, and that's we do by using the transformation of variables. Transformation of variables. Now this property, transformation of variables, you have studied in your advanced calculus books. So basically what we do, we assume a variable z equals to x minus mu of x over sigma of x. Now this property, which I have assumed here, I can, in order to find the derivative of x with respect to z, what I can do, I multiply z by this cross multiplication is equal to x minus mu of x, and now because I'm interested to find the value of x here, I can write it down z sigma of x, this will become plus u, and this is equal to x. Now differentiate it with respect to z, so here we get this differentiation of this term with respect to z will become the sigma only, sigma of x, and this is a constant, it will become 0, and this term will be dx over d of z. Okay, now why I'm doing this, because in order to apply the transformation of variables, I need to have this derivative with me. And for the transformation of variable, this is the formula, if you recall from your calculus. Times d of x over d of z. Now in the next step, what we do, we just plug in our values here. This is my PDF times dx by dz, which is my sigma of x. Now I'm going on the next slide, and there I will plug in my PDF value here because I don't have space here. Okay, I'm going to the next slide please. So this is the form we have so far. F of z into z is equals to sigma of x f of x. Okay, so now I'm going to replace this PDF function here. So it will be 1 over 2 pi square root of sigma x times exponential of this term I just write down a couple of slides ago, 2 of sigma x square times x minus mu of x whole square. Now the next is just the simplification. So when we want to simplify this equation, this term will be cancelled out by this term. So I will have 1 over 2 pi square root exponential of this term inside 1 minus 1 over 2 sigma x square times x minus mu of x. I can also write it down as 1 over 2 pi exp of minus 1 by 2. Now I can combine these two terms. So I can get x minus mu of x divided by the sigma of x. This is going into the square. Now this term we just discussed on the previous slide. This is equal to z. So this my term is basically equal to z here. So what I get here, this is 1 over 2 pi exponential of minus 1 by 2 of z square. Now one thing you need to notice here, because we have transformed our variable x into z, the left hand side is also transformable as it is coming from here, f of z. Now this equation is what we called as the Cdf of normal distribution. This is basically your f of x. Folks, this thing is called the standard normal distribution. It is called the standard normal distribution. Now in the standard normal distribution of z, in the standard normal distribution, this z, the mean value, always remember in the standard normal distribution, the mean value will always be 0 and your standard deviation will always be 1. So this is my mean value and this is my standard deviation. So in the standard normal distribution, the mean value will be 0 and your standard deviation will be 1. Folks, I need to go on the next slide, please. Now, how does the graph looks like for this? So if, for example, this is my axis here, and I have this normal distribution. Okay. And this is my mean value or the median value or the mode, which is mu, and it is equal to 0. Now I'm taking z here. So from the mean value, I can come one standard deviation away. I can go 2 standard deviation away, on the right hand side or above the mean, and I can go 3 standard deviation above the mean. Now I can go 1 standard deviation below the mean, 2 standard deviation below the mean, and 3 standard deviation below the mean. This is how the standard normal distribution graph looks like. Now I just need to go back. Folks, this term that we just studied, it is denoted as phi of z. I need to go on the next slide now. Now there is one thing in normal distribution or standard normal distribution which is called as the empirical rule, or it is also called as the 68, 95, 99.7 rule. I will just write down this rule, then I will explain you on the graph. So this rule says that approximately 68% of the data falls within plus minus 1 standard deviation from the mean. Approximately 68% of the data falls within plus minus 1 standard deviation from the mean. It also says that approximately 95% of the data falls within plus minus 2 standard deviation from mean. I will explain you what does these means actually. The third is approximately 99.7% of the data falls within plus minus 3 standard deviation from the mean. Now what does it mean basically? I'm going to draw this standard curves here. So if we have, for example, this is the curve for standard deviation. And this is your mean value in the middle or the center. Now it says that approximately 68% of the data falls plus minus 1 standard deviation from the mean. So it means to say I add up 1 standard deviation in the mean on the right side. So it will become, this will become mu plus sigma on the right hand side. So this is the mu plus 1 standard deviation. So by that it means to say 1 sigma. Now the same I take out on the left of the mean, which will be mu minus 1 sigma. Now the rule says that this, if you go straight from here and this, now within this boundary 68% of your data falls. So I can say that within this boundary I have 68% of my data. Now the second rule says approximately 95% of the data falls in plus minus 2 standard deviation from the mean. So this is my mean here, and I need to go 2 standard deviation plus 2 standard deviation minus from the mean. So this is my 1 standard deviation. I add up the equal distance, just approximately I'm taking it here now. So this will be mu plus 2 of sigma on the right side of the mean, and the same distance we get it over this point, which is the now the mu plus 2 of the mean, 2 of sigma, sorry. Now the rule says that this area, it has 95% of your data. So I can say that this region has 95% of your data. Now the similar with the third rule, it says approximately 99.7% of your data falls within plus minus 3 standard deviation from the mean. So for example, this is my mean here, this is my standard deviation, 3 standard deviation. So mu plus 3 standard deviation on the right of the mean, and on the left of the mean I have mu minus 3 of sigma. Now this is another area now. So the rule says that if I take it just to show the range of the data, so this range has 99.7% of your data. Folks, I need to go on the next slide, please. Now you need to remember that the area under normal PDF ranges from minus infinity. So your x value will be from minus infinity to plus infinity and is 1. So the area under normal PDF ranges from minus infinity to plus infinity is 1. By that I mean to say the area under this curve is basically equal to 1. Why? Because that is the sum of the all probabilities under this curve, and you know the sum of the all probabilities should be equal to 1, and it is ranging from minus infinity to the plus infinity. Now I will take an example and elaborate more how this rule can help us. Now for example, we have, let's say, a question that for a normal distribution, for a standard normal distribution, what is the percentage of data below 1 standard deviation? Okay, For a standard normal distribution, what is the percentage of data below one standard deviation? So let me draw this graph here again. So if this is my normal distribution curve, just make sure if you are drawing it, it is symmetrical. And because it's a standard normal distribution, this is my mu value, which is equal to 0. And as I mentioned earlier, mu plus 1 will be somewhere here. This is my 1 standard deviation, the distance from the mu. So I can have this as, let's say, so this will be my 2 standard deviation above the mean, 3 standard deviation above the mean. Now this will be 1 standard deviation below the mean because I'm coming on the left side of the mean, and 2 standard deviation below the mean, and 3 standard deviation below the mean. So what is asking for a standard normal distribution, what is the percentage of the data below 1 standard deviation? So if this is my 1 standard deviation, he is asking us to find out all this area. Now here we can use our empirical rule in order to define this. Now from the definitions, you know that this area between -1 and 1 is 68%. We know that from our rule. How do we find out the rest of this area? Now if this is 68% area, so the rest should be, like, if 100 is the total, so I subtract 68, I get 32%. So this means, let me change the color actually, then this can help you. So this means this area, the black ones, this area is our 32%. Now because they are symmetrical, I can divide them equally into 2 parts. So on the left of the mean side, this area is now 16%, and this area is now 16%. So what should be my final answer? So I need to find out the percentage starting from 1 standard deviation. So it will be 68%, which is the area with this one, the red one, and then the black one, which is the 16%. So your answer is the 84%. So this means, how do you interpret this? 84% of your data lies below the 1 standard deviation. We are working on that. If I take you back here, how do you find out these probabilities? We have some tables available. Before I go into that table, let me write down here. This is what we have defined so far. X minus mu over sigma. This is the x variable, this is the x variable. Now I'm going to show you how do we find the probability of this normal distribution. Is this table clear to everyone? Oops, sorry. Okay, is it better now, or this is the table that we use for the standard normal distribution. The first thing, how do we read this table? On the left hand side, you can see that you have this z values. So this left column gives you z score up to 10th place, 3.9, minus 3.9, minus 3.8, minus 3.7. Now the other columns, these values, they show you the 100th place, 100 decimal place actually. So basically, if I'm interested to find out, let's say the value for minus 3.99. So what I will do for the 10th place, decimal place, I will go here. This is my value, 3.9. And then I need to go 0.09 decimal places. So I go to here on this column, and this is my 0.09. So this is the probability value that I am interested in. This is how you read this table. Now this is one table when you have the z value is the negative. As you can see, it is lying on the left side of your mean value, which is the 0. It is a standard normal distribution. Now the second table is the similar one here. Again, you read it in the same way, that this is your 10th place, all this, and this column indicates your 100th place. So for example, I want to find out the probability for 0.16. So my first is the 0.1. I go to my left column on the z. This is my 0.1 here. Then on this column, I find out what is my 0.06. So this is my 0.06. I go down, and the corresponding value to this one is this here. So that's your probability value. Now let me take some more examples here. If you are interested to find out, let's say for 1.9, so I go to my z column, and I will go slightly down here. So I'm interested for 1.9 here. So I go back to my table here. This is my 1.9. Now the next will be 0, 1.90. So this is the probability that we are interested in. Now we will come back to this table, and we'll work on more. So how do we write it? Basically, I just had some values taken for z is equals to 1.9. We write it down as phi of z at 1.9 is equals to, this is the value from the table we just saw, 0.971283. It is coming from the table. Now, what does the z-score tells you basically? It tells you how many standard deviations. Okay, let me write down here. Z-score tells you how many standard deviations you are away from mean. By that I mean to say, if let's say you have z value of +1, this means you are one standard deviation above the mean. because my z-score is positive here. If your z-score is -1, it says that we are -1 standard deviation below the mean. Just keep this in mind. Now, you can either use a positive z-table or the negative z-table. If you are using the negative z-table, positive z-table, and want to find out the negative z, this is the complementary function that you can use. Minus z is equals to 1 minus phi of z, because they are symmetrical actually. Now I will just do one example here. I'm going on the next slide, please. So for example, I'm interested to find out the phi at minus 0.13. So what I will do, I will go back to the tables. My objective is to find at minus 1.8. So I go to the negative z table. Now this is my value of the negative 1.3. Yes, sorry. So this is my values for the negative 0.1, and we want to find out the 100th place as the 3. So this is my column here, which is for 0.03. So I go down from this column. So I just want to see where it coincides actually. So minus, I don't know why I'm choosing minus 1.3. Okay, so this goes down here. So this is my minus 1 point, and this is the value which will provide me at minus 0.13. Now this is 0.448283. So my this value here is 0.448283. Now I just want to show you the formula that I just mentioned. If I find out my value at 0.13 with the positive table, it will come out to be 0.551717. So for example, if you are using only this table, the positive one, to find out the negative, so it will be phi of negative 0.13, 1 minus the phi value at 0.13, and that turns out to be 0.551717, and it will be the same value as for the negative 8283. Now we will do one example here, and which will elaborate more. Height of people in St. John's is normally distributed with a mean of 160 centimeter and a standard deviation of 25 centimeter. Now this guy, his name is Paul. Paul is 172 centimeter high. What proportion? Now, when you will read your textbook, this proportion means the probability. Probability. What proportion of people hides in St. John are lower than Paul's height? Okay, folks, I need to go on the next slide, please. Now, let's draw this and visualize what the problem is here. So this is the, let's say, this is the, for example, the normal distribution curve of this problem, standard normal distribution. So he's saying me that the mean is 160. So in the middle here, this is 160 centimeter. And the standard deviation is 25 centimeter. Whereas the Paul height is 172 centimeter high. So I can say that if this is 160, this will be somewhere, for example, the Paul height, which is 172 centimeter. So we are interested to find out this probability here. So by that, we just need to think how many standard deviation above the mean is Paul's height. And this is the formula that we are using here. X minus mu of x over sigma of x. So I know that x is my 172 minus the mean is the 160. The standard deviation value is 25. When you solve it, you get 0.48. Now what we need to do, we go to, this is our z-score here, we go to our tables and see what probability or the proportion is less than 0.48 standard deviation above the mean, or what is the probability corresponding to 0.48 z-score. Okay, so I go back to my table. Now I need to find out the positive here because it was lying on the right of the mean side. So this is, now this column is basically 0.08, and we need to find out here. Yes, so this is my 0.4. My objective is to find out at 0.48. So I come from here and this is the value here, probability 0.684386. So we get it 0.684386, or I can say 68.43% of St. John people would have the height less than the Paul's height. That's what is the area. of this one. Now we will do one engineering problem. Actually, I'm going on the next slide, please. I hope so far you are able to understand how do we read the tables. We will do one example here. The time to wear out of a cutting tool edge is normally distributed with a mean value of 2.8 hours and the standard deviation is 0.6 hours. He's asking what is the probability that the tool will wear out in less than 1.5 hours. The second objective is how often should the cutting edge be replaced to keep the failure rate less than 10% of the tools. So what is the solution here? Now we know that this problem is related to normal distribution. So if I say this is related to t variable and it is normal distributed, now what is my parameters here? Mean, which is 2.8, and my standard deviation is 0.6. Now in the first objective, he's asking us what is the probability that the tool will wear out in less than 1.5 hours. So we need to find out the probability of t less than equals to 1.5 hours. Now by definition, you know this is the probability of t less than equals to 15. This is equals to your CDF at the value of 1.5. And this is what is also your phi of z. Folks, I need to go on the next slide, please. Now using the z formula, I figure out that t minus mu of t over sigma of t. Now this is, we are interested to find at the value of 1.5. The mean value is 2.8. The sigma value is 0.6. So you get an answer of minus 2.1667. So what we need to find out, we need to find out the phi value at minus 2.1667. Okay. Now there are, let's go to the table now. So I go back to my table and I need to find out my probability at minus 2.1667. So this is here. Now this is my minus 2.1. The next digit is the 6, means to say 0.06. So I come here, this is my 0.06, and the value I have is 0.05386. This is my value. Now as you can see, this number we can round off, and we can also find out the value at minus 2.17. So this is my 0.07. So I can also take into consideration this number. Okay. So I go back here, and on this number I have the value of 0.015386. Just to be very precautious, I rounded off this number, and I also find out my value at minus 2.17. Now what you can do here, and this value was 15003. You can just take the average of these two numbers and find out your answer. So phi of z basically will be, we just average these two numbers. Now at some point you don't need to do the average, that is coming in the next, plus 0.015003 over 2. So once you solve this, your probability at t less than equals to 1.5 is 0.0152. So that's your answer for the first one. Now in the part B, he is asking how often should the cutting edge be replaced to keep the failure rate less than 10%. Folks, I will go on the next slide. So this is the part B here. He's asking to find out the probability of t less than equal to t of r, which is equal to 0.1. Or basically we need to find out our f of t of r when we have the 0.1. If you try to visualize this problem, what he's saying here, if this is my normal distribution, it's not that good actually. So this is my mean value here, and he's saying that it is the 10% of the total, so it will be something like here. So he's asking us to find out this area. So basically he's asking us what z-score gives us a proportion of only 0.10 being less than the z-score. So what your approach should be, if this is my 0.10, the approach should be, we will find out this probability value in our table and then see what is our z-score there. So basically we need to search for 0.1 value in the table and find out our z-score. So let's go back to the tables here. Okay, now one thing I'm sure, because it is lying on the left hand side of my mean value, I will be using the negative z table, not the positive one. Why? Because my concern value is on the left of the mean. So I go to the negative tables here and I figure out, I need to find out all of these, where is my 0.1. So this value is 0.100273. Now here, this could also be the values. Now, because we are concerned to find out the value, we are concerned to find out the value which is not more than 0.10. So I can simply ignore this and take this value. So this will be my z probability values here. So this is my probability value. What is my score? Z score? This is minus 1.2, and the next decimal places is 0.9. So it will be minus 1.29. That is what your Z score is. Okay, let's come back here. So from the table, we figure out that our Z value is minus 1.29. And now because we know our Z values, we can easily calculate our T values. Minus 1.29. I'm interested to find out my T here. The mean value is 2.8. That is your T value. Now, one thing you need to remember, the Z table basically, they gives you the proportion which are less than the certain Z score. By that, I mean to say, if in this first statement, he's asking you that what is the probability that the tool will never wear out in more than 1.5 hours. So in that case, you need to subtract your this number from 1. It is not the objective, but I'm just writing it down here. So in case he will ask you what is the, if it is more than 1.5 hours, so it will be 1 minus your this number, which is 0.0152, and it turns out to be 0.9848. The whole logic is that this Z score, will give you the proportion which is less than the certain score. If you want to find out the rest of them, you need to subtract 1 out of this. Now, if you have X belongs to the normal standard distribution, sigma of X, the probability that X is greater than equal to A or less than equal to B, the formula remains the same. This is f of X of B minus f of X of A. Or I can say this is your phi of Z at Z of B minus phi of Z at Z of A. Okay, let's do one example here. The pitch diameter of the thread on a fitting is normally distributed with a mean of 0.4008 centimeter and a standard deviation of 0.0004 centimeter. The design specifications are 0.4000 plus minus 0.0010 centimeter. Objective is what fraction of product is within tolerance limit. So this is the range of your f of x. Folks, I need to go on the next slide, please. What I'm going to do in this numerical, I'm going to use this formula here. So we need to find out our probability of x greater than equal to less than equals to. Now if you look on your range, it was 0.4000 plus minus 0.0010 centimeter. So at the first time I subtract this 0.001 from 0.4, I get 0.399, and then I add up here, add up this value into 0.4, I get the 0.401. This is the same as you find out your values at 0.401 plus, oh sorry, minus. This should be subtracted. Your f value at 0.399. Now it should be x 0.401 minus your mu value, which is 0.4008 over your standard deviation 0.0004, and the same is for this thing. So this is my phi at 0.5 and this is the phi at. Now the procedure is the same as I repeat. You will look on the tables. So the final answers I'm going to write down here. It is 0.691462 minus this number is 1.59 into 10 raised to power minus 5. Now one thing you will notice, this number, it does not fall within your table. So you will use the formula here, which is 1 over 2 pi, the same formula as we were doing before, e power minus 1 by 2 of minus 4.5 square over 2. And then you will find out your answer, which will be 1.59 into 10 raised to power minus 5. Your final answer for this numerical is 0.691462. Now this is the one way of doing this. If you want to have the more accuracy in your calculations, we can use some computer application. I'm going on the next slide, folks. In the computer application, the very first is that you can use your Excel or the mini tab. Now we have some formulas in the Excel in order to find your phi of z. I'm going to take our previous example here, which we just finished. Now in that example, x is 0.401, mu is 0.4008, and my sigma value is 0.004. And from these ones, the probability I find out was 0.691462. This is the probability that belongs to here. I'm going to show you how we do this in the Excel. Now the formula that you use is the NORM.DIST. Your x value, your mean value, your standard deviation, and then your cumulative function. I will show you in the Excel as well. Now let's go to the Excel and I can show you. So this one I was doing before your lecture actually, but I will start with a new one. So as you know, in the Excel, whenever you want to write down the formula, you need to start with the equal sign and the press NORM. This is asking me NORM.DIST. Now as you can see, this is asking me the value of the X. So in our case, it is 0.401. I need to provide the mean value, which is 0.4008. I need to provide the standard deviation, which is 0.0004. And then for the cumulative, it is asking either true or false. If I choose true, it will give me the CDF. If I choose false, it will give me the PDF. So I click here the true, close your parentheses and hit enter. So this is the probability that we just find out. If you look on your, this is the probability that we are interested in, 0.69146. Now in order to find the z-score, if you use the z-score, now the z-score for this was, let me write it down here. So the z-score for this was 0.5. For the z-score, we use NORM.S.DIST. That's the command that we use. And then you provide your z-score and you choose your true. Now we will do it in the Excel. Okay, so what is my formula here? I started with equal and NORM. I choose .S.DIST. Now it is asking me the value of the z here, which is 0.5. And I'm asking for the cumulative number. And if you hit enter, you will get the same probability value. Now, if you want to find the return of the inverse, okay, by that I mean to say, folks, I will go on the next slide, please. By that I mean to say, if I want to find out, for example, we were doing that if we have the probability of 0.1. This was very tedious and numerical. If you remember, we need to find out the value of 0.1 and see what is our corresponding value there. But from the Excel, you can find it out easily. So it will return the inverse CDF. This is the norm.inv. Then you provide your probability value, you provide your mean value, and you provide your sigma value. Okay, now I will take you to Excel and do it there. So NORM dot inverse, this is what I choose. Now it is asking me the probability value. Probability value was 0.1. The mean of the question was 2.8. Then you have the standard deviation, which is 0.6. And you close your parentheses, hit enter. This was the value that we were interested in for the X. This is the value for your X that we will find out finally. I mean, it was T actually, basically, 2.031. Now, if you want to find out z-score, for the z-score, you can use NORM.S.IN. And you just need to provide your probability value here. This is your probability value, 0.1. So let's see. So I go here, I type the command norm.s.inv. Now you see it's asking me the probability value. So in the questions tray, we have the probability value of 0.1, and it give me the value of the z-score, which is minus 1.281. So the z-score here will be minus 1.281. So these are a couple of the ways that you can work in the Excel. Folks, on page now for this normal distribution, you need to work on examples 10 to 16, and the problems will be 49 to 56. I think these examples starts from page 110, but you can check it. But I'm sure the problem starts from page 117 of your textbook, which is available on D12. Try to work on using the tables and as well as the Excel sheets. I will stop it here. If you have any question, you can ask me, please. Okay, Hadis is asking, is it good if the z-score is closer to mean value? Well, it depends on your system actually. The shape of the curve will change depending upon your standard deviation and the mean, of course. Jeff is asking, is it more accurate to interpret? I think you meant to ask by the table, Jeff? Okay, I think Jeff is asking, is it more accurate to interpolate? I think you meant to say by the tables. Well, it is a tedious job to interpolate tables, of course. They are accurate, but if you have your probability set up to, let's say, 2 decimal places, then you can definitely have the number. But again, as I said, try to have the tables and Excel when you practice these problems and the examples. Folks, is there any more question for me? I'm sorry, I just took, I guess, 5 or 10 minutes more. Yeah, 5 minutes more. We have Sabiuddin asking, is normal distribution, in normal distribution, the area of the whole bell curve is equal to 1? Yes, that's right. In the normal distribution, the area of the curve will be equal to 1. This is why we subtract once we find one side of the area, for the second one we just subtract it from the 1 only, because that is the sum of the probabilities, which is always equal to 1. Folks, just try these examples 10 to 16 and your problems on problem from 49 to 56. And if you have any questions, you are more than welcome to ask me. Is there any more question for me? Okay, folks, I will end this lecture if you don't have any more question. In case you work on this, just try to work in the Excel and the table both. So it will give you some idea how do you work through both of them. And just drop me an email if you have any questions. I can also set up a meeting with you if you think something that you need to discuss. And any kind of the course related problem, just share with me. I will never know your issues until unless you discuss with me. Okay, thank you very much, guys, and have a good weekend.